Hello, everyone. This is Mr. Minnick. I'm so excited to be at school. It's a Wednesday, Thursday, Friday kind of day. I don't even know what day it is. I've been writing the wrong date on everything all day long. It's actually Wednesday, but according to my weekly calendar, it's Thursday, and in my grade. But anyway, so 4.8 is all about counting methods. And in my stats class, we had actually, I can't spell today. It's counting methods. In this stats class, we actually looked at this a long time ago in a land far away. If you can believe how long we've been on chapter 4, it's been since Thanksgiving. We did a preview of counting methods the week of Thanksgiving. That's how long we've been stuck like glue. You and me, baby, we're stuck like glue. Better. Okay. There's a couple things that you're going to need in this particular section when you're doing the homework, one of which is the counting rule. The counting rule. I don't know if that's going to turn out or not. There we go. The counting rule. There we go. Okay, the counting rule is real simple. It can be applied to 2 things. It can be applied to 3 things. It can be applied to 4 things, 5 things. Questions about this come up on the ACT all the time. Example. You will be buying a school lunch, which consists of a sandwich. I'm going to abbreviate. I think that's so cool. Sandwiches are called sands. A sandwich, a fruit / vegetable cup, a drink, and a dessert. Does dessert have 2 S's or 1? 2. 1 S, it's a desert. 2, it's a dessert. Okay. You will be buying a school lunch which consists of a sand, a fruit cup or vegetable cup, a drink, and a dessert. There are either tuna or ham sandwiches, I love me some mandarin oranges. Gotta include mandarin oranges. Mandarin oranges, broccoli. How do you spell broccoli? Is it 2 C's? Broccoli, potato salad, or what's that other one that's real good? Pears, not pears. Pears have, what are the ones that are orange? Those are peaches or pears? Peaches or peaches. Okay, so right here, this is for the sandwich choices. Right here, this is for the fruit cup. Okay. The drink, you could get some white milk, or you could get some brown milk. I'm not going to call that chocolate because that's not chocolate what they put in there. So you get some white milk, some brown milk, or some OJ. Okay, so that's your drink. That's your drink. And finally, for the dessert, you could get dessert is either an apple crisp. That's not bad with whipped cream on it. Apple crisp, a cookie. My dogs like the cookie. Or pudding. Okay. So this is a classic problem that you'll run into that involves the counting rule. Okay? And where they try to confuse you is the language that they use. The language that they use tries to confuse you. They'll say how many combinations are possible for your lunch. Okay? The fact that they use the word combinations is intended to mislead you. It's not cool. It's not fair. But it's intended to mislead you because in a minute we're going to see that we're going to actually use combinations. But how many combinations are possible for your lunch? Well, this counting rule says if there are A ways to make choice A, and if there are B ways to make choice B, then there are A times, or multiply, A times B ways to make choices A and B. So what we're saying is you got to pick two things. There's a certain number of ways to pick the one thing. There's a certain number of ways to pick the other thing. So how many ways are there to make both choices? Just multiply the number of ways for the one and the number of ways for the other. Okay. So this is exactly what we're working with here in this first example. This counting rule example. Hopefully that's big enough where everybody can see. Does anyone have any questions, comments, concerns, short debate so far? So if you think back to the example we did in class, this is where we said, okay, go home and count how many t-shirts you have and how many pairs of pants you have. And let's see how many outfits you would have, assuming an outfit consists of a shirt and a pair of pants. Didn't we do something like that a while ago? Okay, cool. And some of you were surprised that you have a lot more clothes than you think you have. Well, for this school lunch, nobody likes tuna fish. Well, I do, actually, if it's got enough mayo on it. Miracle Whip. Got to be Miracle Whip. With a little bit of hot sauce. And when you take the bread, you got to put butter on the bread to keep the tuna from like melting through it. So then maybe even toast. Toast is pretty good. Tuna on toast. But anyway, I would probably go for the ham sandwich. So how many sandwich choices are there? Okay, so we got two sandwich choices. So when we go to do this problem, this is what we're going to do. We want to say, okay, so we've got to make a choice for the sandwich. We've got to make a choice for the fruit cup. We've got to make a choice for the dessert. And we've got to make a choice for our drink. Okay? So there's a tuna sandwich and there's a ham sandwich. So how many choices are there for the sandwich? Two. So we have two. I said we have two possible choices for the sandwich. Remember, the counting principle says we're going to multiply here. Well, let's go to the fruit cup. The fruit cup, we've got either mandarin oranges or broccoli or potato salad or peaches. How many choices do we have for our fruit cup? We got 4 choices for our fruit cup. So we're going to multiply the number of choices for the sandwich by the number of choices for the fruit cup by the number of choices for our dessert. Dessert, we could get either apple crisp, apple crisp, a cookie, or pudding. So how many there? 3. So we got 3 choices for dessert. And then for our drink, we said we got white milk and brown milk and OJ. So how many choices there? 3. And all we do is just multiply these. So you might think, well, there's not that many choices. Oh, crap, look at all the combinations there are. So we just multiply. How do you multiply? Well, 2 times 4 is 8. 8 times 3 times 3. 8 times 3 is 24. 24 times 3, it ends in a 2. Carry the 1, and I guess it's 72. 72. So the answer, the right way to answer this, the best way is there are 72 possible combinations for lunch. Okay. Is everyone okay with that first example, that first problem? Any questions, comments, concerns, short debates about that? Another instance where this comes up is license plates. Okay, another place where you'll see this is license plate. Example 2, licenses, plates. Okay, the state of Ohio has, I believe, a letter, and a number, and a number, and a number, and a number. All right? That's how Ohio is. Ohio, the heart of it all. How many possible license plates, assuming we just get a standard plate, ignoring or forgetting about the customized plates, if we just go with the standard Ohio license plate, how many possible license plates are there? How would we figure that out? We'd have to take the number of choices for the first letter. How many choices are there for the first letter? 26. How many choices are there for the next letter? 26. We're going to multiply these. How many choices are there for the next letter? 26. How many choices are there for the first digit? 10. And for the next digit? 10. And for the next digit? 10. And for the next digit? 10. So you could get a little creative if you want to. I see so many of you using your smartphones, and I noticed the Samsung Galaxy, actually, from what I've seen, I don't own one, it has a really terrific calculator, but you all aren't using them to its fullest capacity. It's got a terrific calculator. If it has parentheses, use the parentheses, dang it. If it has an exponent button, use that. It's got all that stuff. So rather than taking 26 times 26 and hitting enter, and then pressing time, instead of doing all that, let's just do this in one shot. Let's use some exponent rules. So we're going to have 26 to what power? 26 cubed. Mrs. Carlson, thank you for showing me that I could press math 3 on my TI-83 and cube something. So 26 cubed times 10 to what power? Times 10 to the 4th. And there's that many license plates. That's a lot. What would happen if we said, okay, you can get the farm background, or you can get an Ohio State background, or you can get a veteran's background? That times 3. Does that make sense? Everybody doing all right? Questions, comments, concerns, short debates? We doing okay? Okay. Welp. I guess the next idea we need to look at is this. We've talked about that before. You don't even need to know what that is for the homework, but that says how many ways can you arrange n items. Worthy of noting somewhere is that 0 with an exclamation point is not equal to 0. What it's asking is how many ways can you arrange nothing? How many ways can you arrange nothing? Well, there's really no way to arrange nothing, which is one way. If there's one way to arrange nothing, you can't arrange nothing. 0 factorial equals 1. It's something worth noting. A couple of noteworthy factorials. 1 factorial is 1. 2 factorial, by the definition, it's 2 times 1, which is 2. 3 factorial is 3 times 2 times 1, which is 6. 4 factorial is 4 times 3 times 2 times 1, which is 24. And hopefully that's enough to get you the idea. We'll go up to 6 because you'll see those a lot. 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, which is 720. Okay, those are real common factorials that you will encounter on a day in and day out basis. That's called factorial notation. Okay, factorial. So if you tried the homework and you followed along with the viewing example, you probably ran into that, and you're probably multiplying more things than you need to multiply. Because in the formulas, they give you a formula that goes like this. NPR is n over n minus r, the quantity factorial. And they give you this other formula that says NCR is n divided by n minus r factorial times r factorial. They give you those two formulas. Well, you don't need to use the factorials because your calculator's got these buttons. Your TI calculator has NPR and NCR buttons. Notice I said your TI calculator. I didn't say just your Inspire. I didn't say just your 83. I said your TI calculator. The TI-30 does this as well. The Inspire does this differently than the 83 and the 84, so depending on what calculator you're using, you want to pay attention as we move on in this. Real quick, I'd like to look at the calculation just to see the differences between some of these. Let's go with 4, choose 2, and compare that to 4, choose 2, and see how those are different, because they are different. Okay. According to the formula, 4, choose 2 is 4 factorial over 4 minus 2, the quantity factorial, which is 4 times 3 times 2 times 1 over 2 times 1, and all that stuff cancels, and we get 12. Okay? And in a minute, we'll bring up the calculator and verify that result. One thing to note about combinations are usually smaller. When you evaluate them, they're usually a smaller answer than permutations, because you're dividing by some more stuff. Right there, you're dividing by r factorial more. Because of that, they're usually smaller. So if we did a combination 4, choose 2, it would be 4 factorial over 4 minus 2 factorial, 2 factorial, which would be 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1, and those cancel. And then something else special happens. This 2 actually turns into a 1, and this 4 then turns into a 2. We get 2 times 3, which it ends up being 6. It's smaller. Okay? Permutations and combinations, realize that combinations are usually smaller. So the cool thing about these, if you do the formula by hand, a lot of stuff cancels. If you don't, use a calculator. They do this. I don't think your Samsung Galaxy does, though. Don't think your Samsung Galaxy does, though. So here we go. On my TI-83, I do need to put the N in first. N is going to be bigger than R. N is how many of these things that I have to choose from. So let's see. My calculator decided that it wanted to go to sleep. So if I have 4, I have to put in the 4, and then I bring up the choose. So I go math, and I go over to PRB, and then I go 4, and this time I want the P, the NPR. So 4, choose 2, and there we get 12. If I want to do the combination, I go 4, math, PRB, 4, choose 2, and there I get the 6. Okay? Everybody doing okay so far? On the TI Inspire, this is different than the 84. I'm pretty sure the TI-30 is just like the 84 and the 83, but the Inspire does do these differently, so check this out. It's going to take a minute to load. In the meantime, I'm going to open up a chance for shout-outs. Babs got the first shout-out of the day. So, by the way, happy National Chocolate Mint Day, and happy Iwo Jima Day. So, any shout-outs? Sips gets a shout-out. Bay, okay. Summer. How come seagulls don't live by the bay? Because then they'd be bagels. Anybody else in here really bad at counting? I'm horrible at counting. Not a good counter. You'll see where I'm going with that in a minute, I promise. Well, maybe not a minute, but before this is all said and done, shout out to who? To who? It'll be for the 6th period class. Nicole, Katie, and Marilyn are all in that class. Shout out to Nicole, Katie, and Marilyn. Damn. How did they used to go? Anybody who doesn't hate Dan? Shout out to the future Mr. Minnick. All right, thank you. He'll be back at the desk, sitting down at the desk with his feet propped up on it, I'm sure. Anybody else? Semi-Asian Jeff? He won't even be in there. Maybe he will. Okay, so here we go. 3 weeks later, the TI Inspire decided to join the party. So if you're using an Inspire, write this down somewhere because it's different. On the Inspire, you go menu, and then option probability, and then for a permutation, you choose permutation. And here, it gives you some parentheses, and you put the N first, and then a comma, and then an R. So 4, comma 2 should give us 12, and there it is. Great question. Could you type this in? I'm going to try. I've never tried it on here. So let's try. Let's try typing in NCR. I don't know if this is going to work or not. NCR 4, comma 2. If it works, it'll give me a 6. Hey! All right! Good looking out. So you can type it in if you forget about it. That's pretty sweet. Shout out to Sasha for coming up with that one. Awesome. Good. Yeah, once you start typing something in, if it's recognized, it will go from italics to not italics. Okay. Yeah, we started typing like the NPR. It's small, but then it'll automatically make that full size after the fact. Pretty cool. Pretty cool stuff. Okay. So you might ask yourself, other than the fact that combinations are smaller, what's the difference? Permutations versus combinations. I can spell. Almost wrote combinations. Combinations are usually smaller, not always. Sometimes they're the same size, but usually they're smaller. Similarly, then, permutations are usually larger. But there's one question. If you did the exercises in 4.8, you'll know the answer to this. For one of these, I said for one of these, order is relevant. For one of these, order is relevant. One of these means how many combinations are there if order matters? The other one is how many combinations are there if order doesn't matter? One of these order matters, one of them the order doesn't. And knowing the difference is part of the game for the homework. So what is it? Permutations order is relevant or combinations order is relevant? Let's let the smartboard decide. You say permutations? Yeah, permutations. Order is relevant. So let's look at a couple quick examples. Example, we will choose a president, a vice president, a secretary, and a treasurer from a class of 20 students. This is an example of both. We will choose a president, a vice president, a secretary, and a treasurer from a class of 20 students. How many possibilities are there? So this is where you use one or the other, and you got to choose which one you choose. Do you use an NPR or do you use an NCR? Well, we got to think about this. Does it matter? We're picking a president and a vice president and a secretary and a treasurer. Does the order matter? The order doesn't matter. Let's think about this. Does the president have the same rank and responsibility and role as the secretary? Order does matter in this particular case. It's not an ordinal rank, but it does matter because once we choose the first person, then because the offices are different, order matters. Okay? Because the offices are different, order does matter. Because the offices are different, order does matter. So here what we've got is 20 people to choose from, and of those 20, how many are we choosing? We're choosing a president, that's 1, a vice president, that's 2, a secretary, that's 3, a treasurer, that's 4. So we have 20, and we're choosing how many? 4. So by the formula, this is 20 factorial over 20 minus 4, the quantity factorial, so that's 20 times 19. times 18 times 17 times 16 times 15 times 14. I said times 14. Times da 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 over 16 times 15 times 14. All that's going to cancel. So if you're using a Samsung Galaxy, you would multiply 20 by 19 by 18 by 17. I don't want to do that. I want to use a TI graphing calculator, or a TI 30, and get to this quickly. So on my Inspire, then I could type this in NPR, not for National Public Radio, but for a permutation of 20 items, and we're choosing 4, and we get 11,280. That's not even a number. 11,280. 11,280. Everybody all right with that one? Any comments, concerns, questions, short debates, long debates? We have a question if we could check the Samsung Galaxy to see if it does the permutations. You could check it, but I don't think it does. Okay, same class. Same class. We're gonna pick 4. We're gonna pick 4 people to clean the boards. To clean the dry erase board. All 4 people have the same responsibility to clean and ensure the cleanliness of the dry erase board. So you got to ask yourself, is this a permutation or is this a combination? We're picking 4 people. We're not picking a president and a vice president and a secretary and a treasurer. We're picking 4 people, all of whom are responsible to ensure that the dry erase board's cleaned. We use a combination. So here we use 20, choose 4, which by the formula is 20 factorial over 20 minus 4 factorial times 16 factorial. No, times r factorial, and r is 4 factorial. So this ends up being 20 times 19 times 18 times 17 times 16 times 15 times 14 times all over 4 times 3 times 2 times 1 times 16 times 15 times 14 times This stuff cancels this stuff. And notice how we divide through by another 24. That's a 4 in the denominator next to 20 minus 4, yeah. So what ends up happening, this should be 24 times smaller than what we had. This should be 24 times smaller than what we had. Watch, let me divide my answer by 24, and then let me try an NCR, a combination of 20 items, and we're picking 4. And notice it's 24 times smaller because we divide by that much more. Does that make sense? The way the formulas work, I hope. Okay. So whatever that answer was, it was, what was it, 4485? 4480. Thank you. Dyslexia strikes again. 4845. Okay. So that takes care of that example. We doing all right? We ready, speaking of counting, to see how counting can be fun? We have a comment that permutations and what about permutations and combinations? There's a speculation that the Samsung Galaxy does permutations but not combinations. I don't know which one it does because I don't have one. But here we go. This is just a little question that I saw over the weekend while I was watching TV. I actually learned something from this. You are running a race. So you're jogging along in a 10K. My wife makes fun of runners. I used to run a lot. And she says, well, they look like they're chasing the carrot. She said, every time I see somebody running, I just picture them chasing a carrot. She said, I don't understand why people would run. So you're running a race. You pass the person in second place. Don't shout the answer out loud. What place are you now in? I know you're not supposed to end a sentence in a preposition. I'm sorry, English teachers. You're running a race. You pass the person in second place. What place are you now in? Most people will say that they are now in first. That's what comes to mind. Well, I passed the person in second place, so I'm in first. It's not first. Here's you. Usually when we run this way. Here's the leader. I'm going to write it that way too. The leader. There's the leader. Here's second. So when you are running this race and you pass the person in second, you're still behind the leader. Anyway, we got one more idea to look at here, and it has to do with cards. Cards. These come up in the exercises. Some of the exercises, speaking of which, if you need help with 10, I'll put the formulae for 10 and 11 on at the end of the notes here. But cards, how many four of a kind hands are possible? This is weird because with four of a kind, if you think for a minute, your very first card could be a 1. No, there's no such thing as a 1. It could be a 2, a 3, a 4, a 5, a 6, a 7, 8, 9, 10. Jack, Queen, Ace, or King, right? So how many choices are there for your first card? There's 13. Okay? Now, that's of a particular suit. Okay? So there's 13 cards in a particular suit. Well, then your next card. Remember, we're going to get 4 of a kind. So our next card is all going to be the same card. How many choices do we have then for that next card? 4 of a kind, we have 1 card, and then we have another card that's different, right? So let's suppose we got a 2. If we got a 2, then we couldn't get a 2. So then there's 12 possibilities for that next card, right? But wait just a minute. Now we got to think, okay, suits come into play with this, don't they? So how does that work? How does that work? Maybe I messed this up. Maybe I'm looking at this the wrong way. I think I did. I know I did. Silent night. I said, no, we're okay. I said a silent night. Okay. That was on American Idol, yeah. So I got to multiply this by some kind of combination and by another kind of combination. The one combination I got to multiply this by is there's 4 suits to choose from. There are 4 suits to choose from. So on this first card suit, okay, there's 4 different suits, and I'm choosing how many cards? I'm choosing 1, so it's 4, choose 1. This is how you go find how many how many full houses you could get, or how many 4 of a kind you could get. This comes up in the 4.8 exercises, and this is how you answer. I think the question that this actually comes up in is question number 8. And there's 2 questions that I've seen. It's either how do you get a full house, or how do you get a 4 of a kind, or how many 4 of a kinds are there. So this particular instance is how many possible 4 of a kinds are there. So what we need to do now is we need to think for that next card. Again, there's 4 suits. There's 4 suits, and how many cards are we drawing? We have 4, and we're choosing 4. So if I'm not mistaken, that's how you compute how many possible hands there are for 4 of a kind. That comes up in question number 8 in the exercises. As far as how many possible hands are there, um, does anybody remember how to do that? How many possible hands there are? The first part not right? No, this is all. This is it. Yeah. How many possible four of a kind cards are there? The other one, how many possible hands are there yeah. So if we're using a combination, how many cards are in a deck? How many cards are in a deck? 52. And it doesn't really matter what order we pick them in. If we're just thinking about how many possible hands there are, how many cards are we going to pick when we pick a hand of cards? Standard game of poker. You pick 5. Okay? So let's just look at some of these numbers that we get here. And then that'll probably be it for the day, because the bell's going to ring in a minute or two. Okay, so we got 52, choose 5. That's how many possible hands of cards there are when playing cards. If we take 13 times 12 times 4, choose 1 times 4, choose 4. That's how many possible 4 of a kinds there are. The likelihood of getting a 4 of a kind is very slim. It's 624 out of that 259, 8960. That's why that's one of the best hands you could possibly get if you play cards. If you've ever played, you know how difficult it is to get it, because out of, 2 million, almost 2.5 million, out of over 2.5 million hands, there's only 624 possible 4 of a kind hands. Okay. Real quick, when you're doing the homework, you will get stuck on number 10. Use this formula. 1 minus n, I can't remember if it's a C or a P. N something R. It's either a C or a P. I can't read my own writing. I really can't read my own writing. Over n to the R. I really can't tell if it's a C or a P. I'm sorry. It's a P. Okay. And then in number 11, you're going to use this formula. 1 minus 1 over 2 to the nth. And then the other one, when you get stuck on those, I'll be around to help you. So it's been real, it's been fun. We might have a minute left for shout-outs. Anybody got one? Babs. Kaylee Collins gets a shout-out. Anthony Workman, what's up, mate? Anybody else? Who? The Bay? Somebody's eyebrows? Dan's eyebrows get a shout-out. Who? Britt Nasty. All right. Well, that's it. I hope everybody has a terrific Wednesday. See you next time.